Okay, so we have, for this question, a beam of light with intensity of 43 watts per square meter and a polarization parallel to a y-axis is sent into this system of two polarizing sheets with polarizing directions of θ1 equals 70 degrees, as I've written there, and θ2 equals 90 degrees, as I've written there, to the y-axis. What is the intensity of light that is transmitted by the two-sheet system? Okay, so the thing with this question is that we have light that is coming in and that it already looks like this. So it's already been polarized. So what's it going to look like when we send light in this direction that is 70 degrees from the horizontal, from the vertical? Well, remember, so for example, if this is I0 coming in here, once it's passed through, we can call it I1. Once it's passed through the second filter, we can call it, or the polarizing sheet, we can call it I2. So I1 in this case is going to equal I0 cos squared theta, where theta, remember, is the angle, the relative angle between the polarizing direction. And then I2 is going to equal I1 cos squared theta. Okay, so for I1, I'm just going to do this here. So for I1, what is the angle to our initial polarization? Well, it is 70 degrees. So therefore, we're going to say cos squared of 70 degrees. Now, our initial intensity is 43 watts per square meter. So we're going to say 43 cos squared 70 degrees. And what is that going to equal? That's going to equal roughly 5.03 watts per square meter. Okay, so that's once it's passed through there, and then we need to do the same for I2. Now that's going to equal I1 cos squared theta. Now, this is 90 degrees from the vertical. This was 70 degrees, therefore the difference in between them is going to be 20 degrees. So therefore this is I1 cos squared 20 degrees. Now we need to sub in our I1, which is going to be our 5.03. So we have 5.03 cos squared 20 degrees. And then when we do that, we get roughly 4.4 watts per square meter. And that's how we do this type of question.